Hey, John, I'm just a little too lazy to actually add comments to my Mathematica, so I thought I'd walk you through it here in video. Let's see. So, what I actually do is I made a little function to figure out how far a point would be from the nearest wall of a polygon. So it takes a point and it takes the number of sides in the polygon. First thing I do is I figure out the angle, the typical polar angle that a particle is. And arctan x comma y is great because normally you would think you'd take the inverse tangent of y over x, but of course we know that that has ambiguities in it. But Mathematica is great. If you actually do arctan x comma y, it knows exactly where your angle is. Okay, so what am I doing next here? Well, here I'm trying to figure out what is the remainder of the angle inside of its own piece, right? So if you think of like an octagon, you cut the thing into 8 pieces, and you need to know what your angle is just inside of that piece. And I actually measure everything from the center line to the center of a wall. That's why I do a shift here on the mod command. So mod is the typical remainder command, and I want to know, which piece is it in, but I want to shift it a little bit so that it's something a little bit positive, a little bit negative. And then this is actually the distance to the wall. I'm assuming that the straight distance to the wall is always 1. And then I just take the cosine. So a little bit of math involved there. Okay, so the next little bit didn't actually work, so I'm going to skip it, although it's really interesting. Here's what does work. So I initialize a couple of variables to 0. Someone just twittered me, sorry about that. So let's see. And then in a do loop, I actually calculate, I check to see what the distance is for an arbitrary random variable whose location I store. And here's where the number of sides gets set. Then I say, well, if the distance is greater than the distance to the origin, then increase the number. And oh, by the way, as long as the distance is positive, in other words, you've hit the dartboard, go ahead and increase the total number of shots you've made. So here I figure out the percentage, and in this case it's 0.21749, which I think is a little bit closer. So then how did I do the graphics? Whoops, a little bit too far there. How do I do the graphics? Well, this time what I do is I initialize a couple of lists. I actually only end up using the in one. Very similar here, except the random real, it turns out that you shouldn't always go from -1 to 1. You should actually go out to where the point is in the polygon, not polyhedron. And so that's all this calculation is doing. And here I've decided to do a 7-sider. And the same business, only instead of just adding, incrementing the number that I've actually hit, I append to the in list so that I actually know which points made it. And then I can figure out what the fraction is. And then I do a list line plot where I make the border. That's a function that I'll show you here in a second. And I go ahead and list plot all of the points. And so what you can see here is for the 7-sided one, these are all the points that actually were closer to the middle than they were to the side. And you can start to see the border. All of these, I think these are hyperbolas, portions of hyperbolas, of what made it. And then how did I draw the border? Well, that's actually, it's actually further down here. Sorry. Somewhere down here. Come on now. Here we go. I figured out what the length to the vertex is, and I figured out all of the angles, and then I made the coordinates of all of the vertices, and then I just added the first one back again, and then it's just a list plot to make them happen. And so here you see a few different pictures of the cases. What's really kind of slick is honestly you can just do you can do 700-sided polygon, and it runs exactly the same length of time because, of course, it's just a big if-then statement. So hopefully that's useful, and maybe I'll add some comments to it one day.